Hello, and welcome back to the GWSDAT tutorial series. Today we're going to be covering Plume Diagnostics. This video specifically covers the plume mass, area and concentration, and the estimate boundary sections of the analysis tool in GWSDAT. For this video, we'll be using the basic example as we need a closed plume within our area. As covered in video 4.1, selecting the Plume Diagnostics checkbox in the image spatial graphic delineates a plume concentration boundary and displays the plume diagnostic quantities underneath the graphic. For this particular example, we will be using xylene, as there is a closed plume of xylene displayed in the graphic, giving us a value for the plume mass and the plume area. The plume mass, area and concentration tab itself is located here above the graphic. Here we can see time series data for the plume mass, the plume area, and the plume concentration for each of the time slices. The user can export the complete time series of the Plume Diagnostics to a CSV. The plume threshold in micrograms per litre of the currently selected solute can be adjusted from here. The default is 10. The individual plume threshold values can be set from the settings, which is shown in the settings video. A link to that will be in the description. Note that these plume metrics are calculated based on the units of length entered in the coordinate field of the well coordinates table detailed in video 3.1. If no units were entered, then the relative change in the plume parameters are plotted in dimensionless units. The plume mass is calculated per unit plume depth. To estimate total plume mass, the user must multiply this value by the estimated plume thickness. And by default, the effective porosity of the substance is assumed to be 25%. We can now move here to the Estimate Boundary tab. This function provides a graphic to help you select the correct solute concentration value that will yield a closed plume, which is an essential requirement for the estimation of plume metrics. The plume boundary contour is closed when it does not extend outside the area of the monitoring data. The function works by going through each time step and plotting the minimum and the maximum solute concentrations at the edge of the area bounded by the data. The grey shaded area between the minima and maxima define a region where the plume metrics can be calculated. The red line here is the user-defined plume threshold, which is currently at 10. This line should be chosen to be slightly above the minima, and as you can see, it is slightly above the largest minima here. Thank you very much for watching the video. If you enjoyed, please like and subscribe. If you have any feedback, there is a form in the comments, a link to a form in the comments, which you can click to give feedback on the video.